Okay, good morning. Today we're going to work on parallel and perpendicular lines. Let me write that down. Parallel and perpendicular. Okay, two things that are very common that they'll ask you on a algebra test is, are the lines parallel or are they perpendicular? Now, let's draw them out and see if we can see a relationship between the two. So if I draw parallel lines, so parallel lines are lines, you guys might remember this in 8th grade or 7th grade, are the lines that never touch. So parallel lines are in a sense they're running in sync with each other, okay? And as one rises and runs, the other one rises and runs, and these lines go on forever and they never touch. Okay? They're not like chopsticks where they have to intersect. They're more like lines on a road. Lines on a road or train tracks just keep going in parallel, because if they ran into each other, the train would crash. Or if that happened to you on the road, you get super confused. So these lines are parallel when they pretty much are going in the same direction and they don't touch. Now, in Algebra 1, we're going to describe this in a very simple way. So I'm going to say y equals to mx plus b, right? That's the equation of a line. Now I'm going to split this into two parallel lines. So parallel lines, they both have a y equals mx plus b. Y equals to, we'll say m1x plus b1, and y equals to m2x plus b2. Just to say, because they're totally different. This is line 1, this is line 2. Let me mark this as line 1 and line 2. Okay. So for line 1 and line 2, do they have the same y-intercept? Let me ask you this right now. Do they have the same y-intercept? Looking at the graph, would line 1 and line 2 have the same y-intercept? No, doesn't look right? But what's so special about parallel lines is line 1 and line 2 do have the same slope. So the rise and the run, is actually the same for both those lines. If we think of slope as change, let's say you and your brother have the same allowance, the same change, okay? You both get $5 each a week. Will one of you guys ever be richer than the other? If you guys both make $5 each? What if we're driving on the road? Your car is in front of mine, and we're both driving at 10 miles an hour. Will our distance ever change? You're driving at 10, I'm driving at 10. This is a parking lot, right? Nope, we would be exactly in the same pacing. And that's what parallel lines are. It's a as you grow, so do I. And since we're growing the same way, we are in parallel. You guys have seen maybe on TV where you see planes flying in the air and they're flying in formation. These guys are all flying in parallel. They're all flying at the same speed and the same distance apart. Okay, so when we say stuff that's in parallel, we kind of think that they form these lines that never touch. But one reason why they don't is because they are flying, or they are moving, or they are changing at the same rate. Changing at the same rate. You guys ever see a bunch of elevators go up and they all go up at the same rate, right? They end up being in parallel. Well, the lines are parallel, sure, but the speed at which they're changing, that motor is probably the same motor, and it rises and decreases at the same rate. So this is our main takeaway. Lines are parallel with only one condition. They have the same slope. So lines, let me write this out. Lines are parallel if they have the same slope. And that's going to be m1 equals to m2. Okay? And then we have a special way of saying this. So let's say if m1 equals to m2, then 1 number 1 is parallel to number 2. And this is a symbol here. This symbol is like a vertical equal sign, but when we see the symbol, it almost looks like an 11, right? 2 lines together. This means parallel. So math people like drawing symbols. Instead of writing the word parallel. Okay, let me give you another example. Let's say line A is equal to, whoops, let's not write it that way. Here's line A, y equals to 2 over 3x minus 4, and line B is described as y equals to 2 over 3x minus 100. Is A parallel to B? That's the question. Is A parallel to B? So what do you guys think? Do they have the same slope? So the cool thing about slope-intercept form, remember, it's y equals to mx plus b. That's my m and that's my b. So if we look, the slope in line A is 2/3, and the slope in line B is 2/3. Well, is the slope in A and B equal? 2/3 in one graph is equal to 2/3 in the other. Yeah, they're parallel. Answer is yes. That's the only condition we need for something to be parallel. Let's check a different way. So all these ways I'm doing examples of, you guys will be practicing this in IXL. If I give you a problem, let's do another one. Let's call line A, 2x plus 3y equals to 6, and A equals, so this is my B graph. This one's gonna be a little bit different. My B graph is 4x plus 6y equals to, let's do 18. All right, so I need you guys to practice this right now. Can you change this into slope-intercept form? Y is equal to. Change this to slope-intercept form. Y equals to. Please take a moment and do that now. This is something you guys were asked to practice in the practice quiz right now, in the quiz right now. Again, if you haven't taken the quiz, you guys can take the quiz right now. Okay, I'm gonna do the work on the side. 2x plus 3y equals to 6. I'm solving for y. So we get rid of the 2x and the 3. Make sure you get the order right. We get rid of the 2x first, and then we get rid of the 3. Then divide 3 to both sides. Y is equal to negative 2 over 3x plus 2. Okay, that's line A. Let's look at line B. 4x plus 6y equals 18. We have to get rid of what numbers to solve for y? Slope-intercept form is when y is alone. We practiced that in one of our IXLs already. Get rid of the 4 and the 6. Minus 4x both sides. 6y equals to negative 4x plus 18. Divide by 6 to both sides. Y is equal to negative 4 over 6x plus 3. We can reduce 4 over 6. Reduce that. Can I reduce 4 and 6? We can. Now, we said lines are parallel if they have the same slope. Do they have the same slope? Look at the slope and look at the slope. If they have the same slope, we're winners. So this skill is talking about identifying if things are running at the same speed, right? Not just visually, but looking at the numbers. Okay, we have one more way of determining if things are parallel, and that's looking again at the points. So if I give the points 1, 3, and so line A goes from 1, 3 to 2, let's see, 5. Yeah, let's do this. And line B goes from 7, 2 to 8, 4. Are these lines parallel? Thank you, Paula. So we have equation for points to find slope. Remember, only thing I care about is slope. Are they parallel? We have our equation, m is equal to y2 minus y1 over x2 minus x1. That's my slope equation. So we're going to do this twice for each of these two lines. So let's do it on the right. x1, y1, x2, y2, 5 minus 3 over 2 minus 1. That's a slope for line A. And that's going to be 2 over 1. Let's see if line B has the same slope. The slope of B is x1, y1, x2, y2, 4 minus 2 over 8 minus 1. That's 2 over, whoops, that's a 7. 8 minus 7 is 1. Gaia, go try again. Or Gia, sorry. Go and try again. I opened it up again. Okay, so we have a couple ways of looking for slope. First is obviously if it's in slope intercept form, we're winners. We can just compare it. No work needed, right? No work needed. They both are the same. If they're not in slope intercept form, you have to change it so that they are in slope intercept form. So we solve for y, because that's our slope intercept form, and then we can compare again. Hey, these are equal. That means these lines are parallel. And our last one is, what if I give you 2 points? And say, compare these 2 points. Are these 2 points parallel? And then we have to use our slope equation. And these equations are, again, it depends on which form you're given. We can always manipulate it to change it to find what we want. And in 2 points, I have to find the slope by calculating it using y2 minus y1 over x2 minus x1. Okay? So how is this different than perpendicular? Let's go back and look at a perpendicular graph. You can go back to your notes on top. And a perpendicular graph are when lines cross at a right angle or 90 degrees. So I'm gonna draw a graph. Let's do, I'm gonna go up 1 and run 2. So I purposely made it so I can draw this graph nicely. Okay. So this equation is y equals to, the slope is rise 1, run 2, x, and the y-intercept is 1. So I'm going to draw a perpendicular line here. And a perpendicular line is going to go, instead of positive 1 over 2, here's the rule. A perpendicular line, the slope is negative reciprocal. So if, let's say m1, let's try it another way. Let's say it's m is 1 over 2. That's the slope of this graph here. The perpendicular slope, and I'm going to draw this as upside down t, is negative 2 over 1. So let's pick 0.0, and we're going to do negative 2 over 1. Actually, no, let's pick one over here. Let's do 2, 1. Right, 0.21. Okay. I'm going to draw a perpendicular line by following the slope, -2, down 2, down 2, over 1. So down 2, 1, 2, over 1. And this is my next line. And those are perpendicular lines. Not the best because I'm freehanding this, but you can see that this forms a right angle. So the thing about perpendicular lines are the lines that cross at a right angle. That means they form 90 degrees. It's like a street intersection, right? Where the streets cross and they're perfectly, I don't want to say the word straight, but in a sense, they are angled in this fashion where it forms a right angle. It forms a sharp corner that is what we call 90 degrees. Like the corner of a square or the corner of a cross. They cross and they form a right angle. So here is what we say about perpendicular lines. Perpendicular lines are perpendicular if M1 doesn't equal M2, but M1 becomes -1 over M1. It's a negative reciprocal. Let's look at this more practically. If I give you letters A and B, A over B, the perpendicular slope is -B over A. So our slope goes from a positive to a negative. Let's look at the graph to see if that's true. This is a positive slope going up. The perpendicular will always be the negative version of that. Let's use numbers. If my slope is 5 over 2, the perpendicular slope, M perpendicular, is going to be -2 over 5. They are not the same, because if they're the same, they would have been what we call parallel. And lines that cross are never parallel in the sense, lines that are perpendicular are never parallel. Because if one has a positive slope, the other one must have a negative slope. So let's go ahead and jump down to the bottom and let's look at some examples of perpendicular lines. So if we give you a line that says y is equal to 2 over 3x plus 1, what is the perpendicular slope? Now, I'm going to write this as m with the upside down t next to it, because to describe something as perpendicular, that's the symbol we use for upside down t. Now, just as a recap, we talked about another new symbol today. And the new symbol was that if you see a line that, like a double vertical line, looks like the number 11, this is perpendicular. And if we see an upside down t, this is automatically for us in math to say this is, darn it, what am I doing? I wrote the wrong word. It's a parallel. Oh my gosh. Parallel. And if it's upside down t, you see it's standing straight up. That's perpendicular. I can't squeeze that in there. Okay, perpendicular. So what is the perpendicular slope? Put a question mark there. So the perpendicular slope for this problem is flip it. So 2 over 3 becomes 3 over 2, and stick a negative in front. And you have to memorize that. You have to know that. The big deal is that on the SAT, they might ask you a question like this. And you have to remember the difference between parallel lines and perpendicular. And parallel lines, as a reminder, they're growing the same way. So they have the same slope. But perpendicular lines are 90 degrees to each other. You say yes, they say no. They say up, you say down. You say 2 over 3, they say 3 over 2. So they're running in contrary to you, complete opposite of what you're thinking. Let's do another one. What is the slope of a perpendicular line to, let's say, the number 5, x plus 1? What's a perpendicular slope? Now, as a reminder whole numbers, there's always an imaginary, invisible 1 on the bottom. So could we flip 5 over 1? Hopefully we could. The flip of 5 over 1 is 1 over 5. And don't forget, perpendicular lines are the opposite sign. Let's give us another one. Y is equal to negative 4 over 7x minus 2. The perpendicular slope would be, let's flip 4 over 7. That becomes 7 over 4. And what happens to that negative? It becomes a positive. So let's do our 3 examples of looking at different ways that we can notice if something is perpendicular or not. So the first, let's look at 2 equations. 2 equations in slope-intercept. If I say y equals to 7 over 3x plus 2, and y equals to negative 3 over 7x plus 1. Are these lines perpendicular? The slope for my left line and my slope for my right line, 7 over 3, and the one on the right is negative 3 over 7. Would you say that they are the negative reciprocals of each other? Negative reciprocal. I flip 7 over 3 becomes 3 over 7 and stick a negative sign. Yeah. We can go backwards and forwards. If I take 3 over 7, flip it, that's 7 over 3, and the negative becomes a positive. Again, we have all these different terms that might be the confusing part, but we're learning pretty much 1 to 2 terms a day, which means like 4 terms a week. You learn more terms in Spanish in the first hello than you do in my class. Okay, let's do the other version of this. What if I wrote 2x plus 3y equals to 6, and 3x minus 2y equals to, let's do 4. Okay, are these 2 lines here perpendicular? Yes, when you flip, so just as a reminder, to get the perpendicular, you have to flip it and then stick a negative sign on it. Why? Because if one is positive, the perpendicular must be negative. Right? You say yes, they say no. So you have to do both, flip and negative. That's why we call it negative reciprocal. Okay, let's see if these 2 lines here are perpendicular to each other. Let's go ahead and solve them. Minus 2x minus 2x, 3y equals to negative 2x plus 6. And then divide both sides by 3. Y is equal to negative 2 over 3x plus 2. On the right, minus 3x minus 3x. Negative 2y equals to negative 3x plus 4. I'm going to divide both sides by negative 2. Careful, I'll divide everyone by negative 2. Y is equal to negative becomes a positive 3 over 2x. And positive divided by negative, positive 4 divided by negative 2 is a negative 2. Mr. Ko, positive 2 and negative 2 aren't the same. That's not what we're looking for perpendicular. We're looking at specifically the slope. And is the slope a negative reciprocal? Flip 2 over 3. Does that become 3 over 2? Yeah. And a positive becomes a negative? Yeah. These are perpendicular. So negative 2 over 3 becomes 3 over 2. Yeah, that's my slope. So yes, perpendicular. Okay, let's do one more when it comes to lines. Let's do 2 points. The point is 5, 2, and 3, comma 4. And our next point is 1, comma 2. And we're going to move this to 3. Oops. Sorry. That's fine. We'll do 3. Four. Let's check if these points are perpendicular. Well, what's the slope of line A and line B? So to find slope, we have our equation y2 minus y1 over x2 minus x1, which really just take a y and subtract the other y. 4 minus 2, then take the x and subtract the other x, divided by 3 minus 5. This will leave us 2 over negative 2, which is negative 1 over 1, which is negative 1. Let's look at the right side over here. y2 minus y1 over x2 minus x1. And I'm not afraid of writing the formula again. It's going to help me out. 4 minus 2 over 3 minus 1. This is 2 divided by 2, which is 1. Oh, we can rewrite it as 1 over 1. 1 over 1, which is 1. Now, are these negative reciprocals of each other? If you take negative 1 over 1 and you flip it, it's still 1 over 1, right? And the sign becomes a positive. Yeah, these are perpendicular. And that's what they'll ask you sometimes. They'll ask you, are these lines perpendicular or parallel? It's really just a game that we have to play. It's a puzzle, and we're solving this puzzle. Now, we have one more thing we need to do today, and this is really the algebra part of it. This last part, we're just identifying when things are perpendicular and parallel. But this next part is we are going to write the equation of a perpendicular or parallel line. So write the equation of a parallel line. Write the equation of a parallel line. Now, I'm going to start this off pretty easy. I'm going to give you the form, point-slope form. So this is what we call point-slope form. And point-slope form, remember, is y minus y1 equals to m, x minus x1. And all these questions always come up in the same type of setup. They give you the original line, and then they say, hey, I want you to write a new one. I want you to write me an improved version of this, a parallel line. So here's our original form. So y minus 3 equals to 2, x minus 4. Okay, that's it. And there's always going to be some weird one. And they're going to say, write a parallel line that passes through, let's give you a number, 2, 8. And you might say, man, this is a lot of work. Shoot, what am I supposed to do? Now, here is the trick I need you guys to critically think. Do you want us to write a line? Sure, we have a lot of ways of writing a line. We have standard form. We have slope-intercept form. And then we have point-slope form, which we just wrote, right? So we're going to decide which type of line we're going to write based on the information that we are given. So to write a parallel line, we need to make sure the slope is the same. Looking here, what is the slope of this equation? This is the critical thinking part, right? Which is the slope in this crazy XY number thing? if we know the form, we can automatically tell you what's a slope. By decoding it, the slope is 2. No work needed there. There is no work here. We're just identifying the parts. The 4 is an x, the 3 is a y, and the 2 is my slope. Is everyone okay identifying 2 as a slope? Because the slope is in front of the parentheses. And hopefully you worked on IXL and you're able to figure that out pretty quickly. So we know my new line, the m, must be 2. What other requirement did they tell us? They told us this new line, right? This is my new guy, new in stores. My new line has to have a point 2, 8. All right. So we have a point slope form right here. So which equation do you think I'm going to use? Standard, slope intercept, or point slope? We have a slope here and a point. I want you guys to be able to identify which one to use, and we're going to use point slope. Why? Because we have a point in slope. So let's set this up. Y minus y1 equals to m, x minus x1. Let's label the point. This is my x1 and y1. So we're just going to copy that in. Y minus 8 is equal to 2x minus 2. Where's this 2 from? This 2 is from the x1. You're going to set it up. From this, we're going to write it, change it to slope intercept form. And that's what Schoology is going to ask you for. Sorry, not Schoology. IXL is going to ask you to write this in slope intercept form. So to write this in slope intercept form, we're going to distribute and solve for y. Let's do that. Y minus 8 is equal to 2 times x is 2x. 2 times negative 2 is negative 4. And let's just move the 8 over. So plus 8 to both sides. Y is equal to 2x plus 4. That is our new parallel line. We can double check it. What's the slope of my original line? It was 2. Great. If the slope is 2, my new equation must have a slope of 2. Yes, we do. And the point must cross through 2, 8. If I plug in 2 here, double check. If I plug in 2, do we get 8? 2 times 2 is 4. 4 plus 4 is 8. So this does work also. If I plug in 2, do we get 8? Yeah. So let's do this one more time. So they can give it to you in many different ways, but let's go through one of the hardest ones, I think. So here's my next example. And the example says, my line equation is y minus 5 is equal to 4x minus 2. Okay? Actually, no, let's do a fraction. Okay? Let's do a fraction because they might give you a fraction. And then they want us to go through point. Let's do 3, 2. So we write parallel, crossing through 3, through 3, 2. We want a line that's parallel and passing through 3, 2. So to write this line equation, we need to steal the slope because that's the only thing that relates parallel lines is a slope. And we need a point. Yeah, we got a point. Point is 3, 2. So let's write this out in point slope form. So slope is 4, 3, and our point is 3, 2. Okay. How do we know the slope? Well, remember, this is in point slope form, and the slope is in front of that parentheses. So this is the only thing we take over to our new home. So we write our point slope form. Y minus y1 equals to m, x minus x1. So y minus, is 3 or 2 the y? 1. Well, xy's, this is the ordered pair, so this can be a 2, is equal to slope 4 comma 3, x minus the other x. So I'm not taking this 5 and 2 here. I don't care about my old house. All I care is I'm taking what I want with me, my slope, into my new house. Now let's go ahead and multiply this out. 4 minus, darn it, that's a y. Y minus 2 is equal to, let's multiply the 4 over 3 out. 4 over 3 times x is 4 over 3x. Now over here, 4 over 3 times negative 3. You could do it 2 different ways. 4 times 3 is 12. Negative 12 over 3 divides out to become negative 4. Or you can just divide out the 3's. So it's 4 times negative 1, which is negative 4. Practice both those methods. Negative 4. Almost done. I'm going to solve for y. So I'm going to get rid of this negative 2 to both sides to become a positive 2 to both sides. That is my new equation. Does this change for perpendicular? No, perpendicularly follow the same type of rules. So I'm going to do the same equation now. This time, not same equation, same type of problem, but I'm going to give it to you in slope. Y equals to 3 over 2x plus 1, and with a perpendicular crossing through 3 comma 2. So we want to write a new line that's perpendicular now. Well, perpendicular has a different type of slope. So let me ask you, my slope before was 3 over 2. What's the new slope? My new perpendicular slope? Is it just 2 over 3? I forgot something. What did I forget? I forgot the negative sign. So not only do you flip, but also don't forget the negative. And our point is 3 comma 2. So we have everything we need for our new line equation. So let's set this up. I have a slope and a point. So guess which form am I going to use? I'm going to use point slope form. Y minus y1 equals to m, x minus x1. So y minus y, is that 3 or 2? X and y, that's going to be 2 for us. My slope is negative 2 over 3. My x is, remember that's my point x, 3. Now this is like the last two problems we worked on. We have to simplify it. So we're going to multiply out the 2 over 3. Y minus 2 is equal to, okay, 2 over 3 times 1x is just 2 over 3x. Please take that as always a freebie. And 2 over 3, negative 2 over 3 times negative 3. You can multiply it out. 2 times 3 is 6, a positive 6 over 3. That's 2. That's great, plus 2. Or if you want, you can divide out the 3's, and we're left with a negative 2 and a negative 1, which still gives me 2. Both ways work. Almost done. I'm going to plus 2 to both sides because they want slope in intercept form. Y equals to 2 over 3x plus 4. Okay. All right. So we worked on similar skills today, identifying slope, telling whether it is parallel or perpendicular. And then from there, we're able to now write new equations with our lines being parallel or perpendicular, given a point. And that's really what your IXL is going to be working on today. First part is to describe the slope of a parallel or perpendicular line. The second part is to write the equation knowing what the parallel, knowing what the perpendicular line would be. Okay. And this is really working back to day one about simplifying an equation, solving for variables. Okay.